Year 12s, Year 11s, I'm going to go through some of the questions from Exercise 3K just to give you, an idea of how to do the questions. But here we go. Question 2, let's have a look at question 2. It says, a family of parabolas have rules of the form, and they give you y equals to ax squared plus bx plus 4. Given that a can't equal to 0. Now that makes sense because if a was equal to 0, well then you're not going to have a quadratic equation because 0 times x squared cancels out the x squared. And without the x squared, you don't have a quadratic equation. So that makes sense. Okay. Now a it's pretty easy. A, find the discriminant of the quadratic polynomial equation. Now we know discriminant is equal to b squared minus 4 times a times c. And what we can see is our a is still a. Let me just highlight them. So this is my A, that's my B, and remember the last number is your C. So if I were to just use the formula, then it just seems like it's B squared minus 4 times A, which is still A, but times 4 is what my C is, and that gives me now B squared minus 16A. Okay, so that's answering the question. That's my discriminant. B, it says, for a parabola in this family with its turning point on the x-axis, find A in terms of B. Now, when it says turning point is on the x-axis, that means you only got one x-intercept. Turning point on the x-axis implies that you have one x-intercept. Now, the only way to have one x-intercept is if the discriminant equals 0. Remember from exercise 3I. So, if it equals 0, then you can find out the turning point. Now, meaning that you have one x-intercept, sorry. So that means if it's equal to 0, discriminant is equal to 0, then you have b squared minus 16a equals to 0, because that's your discriminant equation, true? And that's my 0 there. So now I've got an equation, 0, but they ask you to find a in terms of b. So find a. Now what I would do is I would say add 16a on both sides, just because that's a minus 16a, so opposite of minus is add. If you do the opposite, you now get 16a equals to b squared. And finally, you want to find a in terms of b, so divide both sides by 16, you get b squared on 16. Okay, so that's part B. Finally, now we're going to part C. If the turning point is at negative 4, 0, find the values of a and b. Now this is interesting because you now know when x equals negative 4, y equals 0, and this is your turning point. Alright, if it's your turning point. Now, what I can see is there's a problem because this is an equation where you have two unknowns and they've given you a piece of information for you to solve the second point. You need two equations, two unknowns, and I haven't shown this formula to you, but the turning point formula, just to find the x coordinate, there is a formula. It's x equals negative b over 2a. Okay, that will tell you the x coordinate of your turning point. I can't prove that to you now because you haven't learned calculus yet, but for any general equation, y equals ax squared plus bx plus c, to find the x coordinate of your turning point, okay, so for your turning point there's always an x and a y coordinate, then the x coordinate can be found by taking the b term, negative b divided by 2a will give you the x coordinate. I'll explain that tomorrow in class again just to make sure everyone's got that formula, but that's an alternative. Instead of completing the square to find out the turning point, you can also do it this way. This works too. I think you're going to use this formula just because there's an a and a b in this equation and you need an a and a b. Yeah. So since the x coordinate is equal to negative 4, we can say therefore this will give me negative 4 is equal to negative b over 2a. Now you got equation 1 and you got equation 2. So it's likely you'll simultaneous it. What I would do is I'd probably multiply both sides by a negative, because if I multiply this by negative 1 and multiply this by negative 1, the negatives cancel out. True? Two negatives make a positive. So then you end up with 4 equals to b over 2a. I personally don't like fractions, so what I would say is times 2a on both sides because 2a divided by 2a, this is going to cancel, it'll be 1. True? A divided by a and 2 divided by 2, they're both 1s. So now you get b over 1, which is b, and 2a times that, that's 8a, and so there we go, we got 8a equals to b, and that looks like a better equation to call number 2. Okay, so that's my equation number 2. Now to put it together, I've got also a equals to b squared on 16. So if I put it together, replace a here, I have 8 times b squared on 16 equals b. 8 and 16 becomes 1 and 2. So now you've got b squared over 2 is equal to b. If you multiply both sides by 2, then you get b squared equals to 2b. Minus 2b from both sides, you get this nice equation, and that's using quadratics again. So you got b squared minus 2b, you can take out a common factor of b minus 2 equals 0, and conveniently this is a null factor problem. B could either equal to 0 or b minus 2 equals to 0, and therefore b is equal to 2. Okay. So it seems like I got 2 answers now. So if b, so let's go again. If b equals to 0, then a equals to 0 squared on 16. Yeah, I'm just following this formula that we had. And that will give me 0 as well. But we also know that from the very first condition, it said a can't equal to 0. So since a can't be 0, therefore a doesn't equal to 0. Okay. Whereas the second condition was b equals to 2, then a will equal to 2 squared on 16. That's what, 4 on 16, which gives you a quarter. So that means it's likely a equals to a quarter and b equals to 2. Okay, that's a weird and long-winded one for 3K, but oh well. Question 2. How about that? Alright, let's have a look at the next few ones. Next few ones should be easy. Let's have a look at 3. I'm just going to move this across just so we can keep working on with more spaces. Okay, let's have a look. 3. Question 3, it says a parabola has x-intercepts. Now remember, in exercise 3K, I mentioned there were 3 types of equations you should remember. There was equation 1, which is the general form, y equals ax squared plus bx plus c. There was the turning point form, which is y equals a bracket x plus b squared plus c. And then there was the x-intercept form, which is a times x plus b, x plus c. Okay. And I gave you tips. I said that if you're given a turning point, you're going to use this turning point form. If you're given x-intercepts, but it has to be 2 x-intercepts, you'll be using this form. And if you're not given either a turning point or 2 x-intercepts, then you'll be using this form, which we all don't like. Question 21 is this. I'll show you how to do it on a calculator. You can do it by hand, just takes ages. But this is when you don't have any turning point and you don't have 2 x-intercepts. You might have an x-intercept, then you'll need 3 pieces of information for this one. So 3 pieces of information in order to solve it. Okay. In our case, question 3 tells us that it passes through 2 x-intercepts. So we can use this form of equation. Okay. So question 3a, I'm going to say, well then the equation must be y equals a times x plus b, x plus c. Now they already told me the x-intercept is -2 and 6. So that means for you to get an x-intercept of -2, this had to be x plus 2. And in order for you to get 6 as your x-intercept, then this had to be x minus 6. Okay. That's so far what we've gathered just from these 2 pieces of information. Because as we said, if you're confused by that, if I gave you this, hypothetically, if I gave you this equation in your quiz, I said x minus 1 and x plus 3, and I ask you what does x equal to, what you would naturally say is x equals 1 and x equals -3. So very similarly, if we know now if x equals 2, then this has to be plus 2. True? It's like reversing. Okay. So now that we know this is our equation, we're only missing a because we don't know what a is. So that's why they gave us another point. They said when x is 1, when x equals 1, y equals to negative 30. So I can apply it in. I say, all right, well, y is equal to negative 30 equals a times 1 plus 2 and 1 minus 6. This works out to be, what, negative 5 times 3 is negative 15a 30. So therefore a must be divided by size by negative 15, and that gives you 2. So my equation will have to be y equals 2 bracket x plus 2 x minus 6. Okay. But there we go. So we've done question 2 and we've done question 3a. If we have a look at question 3 is nice to summarize everything together actually. So if you have a look at 3b now, so I said there were 3 types of equations you'd use, right? So here we go, look at 3b. 3b says coordinates of the turning point of a parabola are negative 2 and 4. So that already tells you, you know the turning point is at negative 2 and 4. So you will be using the turning point form, which is a bracket x plus b squared plus c. And because you know the turning point is at negative 2, 4, that's a hint. So negative 2 means left by 2. Think about it. Negative 2 is over here and up 4. So left by 2, the only way for that to happen is if this was x plus 2 squared. Okay? And the only way for it to go up is if this was plus 4. Okay, so that's how you get that term there. So now the nice thing is I've chosen the correct equation and I only got a to solve. So I just need another coordinate. If I get a coordinate, so it tells you it passes through 3, negative 46. Then when x equals 3, you get negative 46. So a 3 plus 2 squared plus 4. So let's see. Minus 4 on both sides, that becomes negative 50. A times 5 squared becomes 25 to a. Negative 50, and divide both sides by 25. Negative 2 equals a. Okay, so that means my equation must be y is equal to negative 2 bracket x plus 2 all squared plus 4. Okay, that's 3b. Now 3c, which is what I didn't get to teach in class, it says the parabola passes through the points. Now, none of these are your x-intercepts. This is your y-intercept when x is 0, it's negative 3, but there's no turning point either. So I told you that if you don't get anything, it's likely that you'll need to use the general form. Now to do this, question 3c, it's really just the substitute. The form that we're choosing is y equals ax squared plus bx plus c. Okay, and this is because there are 3 unknowns a, b, and c. That's what you have to solve. You need 3 pieces of information, which they've given you. They've given you 3 coordinates. Okay, so that means when x equals 1, then y is negative 2. So that's what I'm going to do. I'm going to sub it in. So it's negative 2, a times 1, which is a, plus b plus c. That's my first equation by subbing 1, negative 2. Second equation is when x is 0, y is negative 3. But that's already implying that c equals negative 3. Again, how do I know? Again, same thing. 0, negative 3. Let's apply it. That becomes negative 3 equals a times 0, which is 0, plus b times 0, which is 0, and then you got your plus c. So c equals negative 3. Okay. And then finally, you got the third coordinate, which is negative 1, negative 6. So when x is negative 1, y is negative 6. So if I apply it by the same logic again, negative 6 is equal to a times negative 1 squared plus b times negative 1 plus c, which we know is negative 3. But here we go. That becomes a minus b plus c is equal to negative 6. All right. And your job is to simultaneous equations so that you figure out the solution. Now you can do this by hand or you can do it algebraically. Now if I were to do it by hand, I already know c is negative 3 and c is negative 3. So this gives me 2 new equations. It's negative 2 equals to a plus b minus 3. And this equation is negative 6 equals to a minus b minus 3. Okay. You got two unknowns, and in order to solve this case here, what we're going to do is we're going to say, let's add 3 on both sides here. Just collect all the numbers together, and what we get is -2 plus 3 is -1 equals a plus b. And this one, adding 3 becomes -3 equals a minus b. Okay. Alright, so now I've got two equations, and I can do elimination method to try and solve this. So let's have a go. We've got -1 equals a plus b, and we've got -3 equals a minus b. I'd say add both equations. 1 plus -3 will give you -2. A plus a is 2a, and b plus -b cancels out, so a must equal to -1. Now, if a equals -1, then according to our equation over here, or this one, doesn't matter which one you choose, but then if a equals -1, in that case, subbing -1 in, you got -1 equals a plus b. So a is -1, therefore b is 0. Add 1 on both sides. That doesn't make sense. Wait, I must have done something wrong. Let me double check. A is -1, C is -3. Yep, no, I did do something wrong. Sorry, I got to substitute a equals -1, not into these, because I used these to get the answer. You got to sub it back into what the original equation was. Okay. No, actually. Wait. -1, -4. -1. Did I copy something wrong? I think I might have copied something wrong. -2 plus 3 is 1. Whoops. This is meant to be 1. So my elimination method is okay. Yeah. And that gives me 1 minus 2, 2a, yeah, a equals -1. So if I sub it in -1, b is still equal to 0. No, -1. Okay, so that means 1 equals -1 plus b. Therefore, b has to be 2. Okay, there we go. Now, we can do this by hand, or we can do it on a calculator, which I'll show you. Here we go. So, you can also do this on a calculator, which I didn't get time to show you in class. But here we go. We want to solve. So, when you go to, you turn on your calculator, you got your calculator button, click it in, go to menu, algebra, which is, so that's what you're doing, 3, and you're trying to solve. In our case, we were trying to solve which equations? We were trying to solve that's right. We were trying to find A, B, and C if you had 3 coordinates. Actually, scratch that. Don't do solve. We're going to do what I always tell you. Menu 1 to define. I want you to define f of x. Okay, so it's f and then bracket x bracket is equal to a times x squared plus b times x plus c. Okay. Notice I'm writing b times x rather than bx because the calculator won't know that these are 2 different numbers, b and x. They just think bx is the same number. So that's why you make sure you got to write a times x squared and then plus b times x plus c. Okay, I just realized it's bolded, so it means I haven't cleared out what I had used in the last file. So let's see if I can clear out A to Z. Gotta type it all again. Alright, let's do it again. Here we go. So define f of x equals to a times x squared plus b times x plus c. Done. Okay, so now that I've defined it, then I wanted to solve, which is the next one, right? Now solve. What do I want to solve for? I have 3 points. So I'm going to use this one over here. How do I get there? See, in between the 9 and the book, there's this button. I get this box up and I choose this. I say solve for 3 equations. Now the reason why I want to define it is because instead of typing sub x in like 1 when x is negative, when x is 1 and then sub y in is negative 2, that takes too long. What I would do is then it's f of, now notice, see where the x is, I want when x is equal to 1, y is negative 2. So that's what I write, f of 1. So when x equals 1, the whole thing equals negative 2. Same thing with the next one. It says when you sub in 0, you should get, negative 3. Okay, so if I sub in x equals 0, I should get negative 3. And then finally, if I sub in negative 1, I should get negative 6. So here we go. F of negative 1 equals to negative 6. Okay, so I'm telling you to solve, like telling the calculator to solve that, but they don't know what they're solving for. Are they solving for A, B, and C, or they're solving for X? In our case, we want to find A, B, and C. So you do comma A, comma B, comma C. All right, press enter. Should be the same answer as what we got before. Oh, whoops, I forgot to put the brackets. So solve, there we go. And see how the answer is exactly what we got before. We said A was negative 3, and we've got that there. C equals negative 3, and then we figured out A equals negative 1, which is true. And then we worked out B, which is 2. Okay, so learning to solve simultaneous equations, but using the define. See, that's much quicker than replacing all the x squares with a 1 and then saying equals negative 2. It takes too long. This is much quicker. Okay, I'm going to pause the video here because I think that's a good sort of practice just for the first 3 questions there. Choosing the 3 main equations, 3 pieces of information, turning point, and 2 x-intercepts. Okay, I'm going to make more videos on 3K as well, but I'm just going to post this just to get you thinking. Okay.